Hello and welcome to TidyX, a screencast where we go through and explain how code works. Today we're going to go through some Tidy Tuesday code that was submitted. It's pretty great. Before we get into that though, my name is Ellis Hughes. I am a statistical programmer at Fred Hutch Cancer Research Center.
And I'm Patrick Ward. I do data analysis in sport, and you can always hit the both of us up with questions about things you might see on the podcast or things you might have seen on Tidy Tuesday that you'd like explained. You can find us at tidy.explained@gmail.com.
You can also find us on Twitter. You can find me at Ellis_Hughes.
And I'm at OSP Patrick.
All right, so the data this week from Tidy Tuesday is a fun one. I think a lot of people on Twitter had a good time exploring this data, even if if you're not interested in Broadway, because it was Broadway weekly grosses. So this is coming from Alec Cookson. So thank you for submitting it and doing all the cleaning. I know Thomas appreciates that. So Jake Kaupp took this data here, and he had a number of likes. There were some pretty great ones this week. But this, we thought, showed a really unique way of exploring this data where you can show the trend overall across all of the other plays. But then he was fascinating in showing explicitly how specific plays performed across the various years. So we thought that was really interesting, and that people might also be interested in learning how to do that. He shared his code on GitHub. So this is his code here. So we took this and we copied it and put it into our studio session. So we'll go through that now. So getting started, Jake has the first bit where all his packages are being loaded in the very beginning here. Like we said, that's really great to be doing here. So he's bringing in tidyverse lubridate here for keeping stuff in a specific location. Additionally, he has this library jkmisc. And so this is actually a package that he wrote himself. So he serves it off of GitHub. And so you can install packages that are served off of GitHub using the remotes package. That's available through CRAN. And so you can just download it through that, or this function here, remotes install GitHub, with the username and then the actual repo name. And so now I have library jkmisc available on my computer, so I can use code that he's written whenever I want to. Then he's using glue and scales from formatting, and ggtext for locating data onto his plots. Next, he loads the data in using their slugs. You could also use the Tidy Tuesday R package to be loading it simply and bring the README and whatnot into your RStudio, but this way clearly works. So the next step is he's doing some initial processing that he's generating, and then generating a data set called corrected. So the first step is he takes let's actually run all that before I get too far and start airing out. All right. So load in the data. He's doing the read CSV, and then he uses grosses, and then he does this unique bit here where he's using this function glue, which comes from the glue package. And glue is a really great way of handling strings and pasting them together, where he's actually able to define an R function using these curly braces here. So we're using the year function from the lubridate package and month from the lubridate package, and taking week ending and the year and the month from week ending, and generating a new data set called year month, or new field. He's joining in the CPI data set, which has a consumer price index, so that's what CPI stands for, and the year month that it occurred for. He then does some normalization techniques. So he takes the first CPI record and divides all the CPIs by that, so that you get a scaling off of that first year of CPI, and does some normalization across the years. So that's a good way to be doing that. So let's run that. All right, Patrick, do you want to take this next chunk?
Yeah. So the next thing he's doing here with the that corrected data set that data frame that he just created, he's grouping by show, and then he's looking for the number of runs that every show had. So The N distinct there is basically identifying the distinct year for each show. And he does a little bit of work here to then filter out only the shows that were at a runtime of 5 or more years. So kind of get rid of the shows that may have been a 1 weeker or a special feature for a month or something like that. So he can look at the long running shows, which will help him produce those long-term trend lines. Essentially, what you're looking at then is the top grossing shows across time.
Mm-hmm. At least in the last 5 years.
In the last 5
or
years, yeah.
Up to the last 5 years.
Well, yeah, correct, yeah.
Yeah. So like Phantom of the Opera, Chicago, Cats, Wicked.
The frequently, I guess, talked about ones.
Yeah. Wow.
Popular. Yeah.
Phantom of the Opera has 13,000. Wow. I didn't realize it had been around for that long. So next he takes the corrected data set and does a semi-join with long shows. So this will, I forget actually what semi-join does. Do you remember, Patrick?
I can't remember semi-join. I mean, let's see what it...
let's see. All right. Returns all the rows from X where there are matching values in Y, keeping just the column.
Oh, that's right. So he's effectively removing the extra columns from the Y data frame. In this case, the Y data frame being long shows. Mm-hmm. He's keeping all of the corrected columns, and he's only joining onto, or essentially filtering out, those rows where the corrected columns have a match to the long shows data set.
Yeah. All right, so then he does a similar group by show. So now for each show, he's calculating the weekly gross and calculating a cum sum. So we've covered this in prior weeks, so it's going to add up to the prior week, and it grows as for each entry in the vector. So it's going to match the same length, and it'll cumulatively sum each of the rows there. So then he creates that to generate the money data frame there. And now he finds top 10. So what he's doing here is he's going to find all the cases. So this is an interesting way to do it, but he's trying to keep only the records, the last case where they, so the last time that they get a record. So that'll be the equivalent to this. So when is the core weekly gross equal to the maximum? Then he does an ungroup. So before it was grouped by show, and then finds, okay, what are the top 10 shows based on the weekly gross? And then does an arrangement and a left join with long shows. So now he's only got the cases where the show was a top 10 and he has all the information about them. Next, he does a pull. So this is going to, out of top 10, keep the show vector, right? And now he's going to be mutating this top 10 to generate this IDX field. So this is based on show, but it's now going to be an ordered factor. Mm-hmm. All right. So this step here, we went through this. I had actually never used IMAP DFR, but it is similar to the map DFR, it looks like. So he's got this kind of all written out in one line. I find that a little bit difficult to read at times, so I like to, after my commas, clear it out just to make it a little bit easier for me to run. So what he's doing is here is he's pulling out show. So pull the Lion King. So for each of the top 10 shows, he's going to do a left join with money out of select top 10. So he's combining those two to generate a really long data, or a really long data frame. And all of this is now going to be for each of these shows, perform this mutation, or perform this join, then mutate. And if the show is one of those, or for each instance, one of these top 10 shows, set the color vector to be this hex value, otherwise an NA character. Alpha, set it to 1, size set it to 1.5, and the IDX field set it to also be the show name. All right. so now he's got these vectors that either have this value or an NA. So he does this replace NA. So for the color field, replace it with this value here, alpha with this value, and size with this value. I'm not quite sure why this wasn't done in this step here, but there probably was a reason that he couldn't be putting these values in there. There's some conflict, probably.
Yeah.
Then he does a mutate to set these to be a factor. Also with IDX to set it to be a factor that matches the same levels as we were doing before and arranges it by IDX and color. So for
this was the important step, because this is how he gets essentially the colored line and all the gray lines in the cool plot that we saw, isn't it?
Yeah. This is the critical piece of that to generate the ghosting.
If you had just done a facet wrap, you would have been privy to only the data within that facet.
Yeah.
But in order to make the line compare to the entire population of shows that were running at 5 or more years over that time, he needs to create this long data set that reflects the show that's in the color relative to the other shows of the population that are in gray.
Exactly. Yeah. And so now we end up with this, rather large. It's got 196,490 rows. So it's not small, for sure. But that's, we've got lots of data going on here. Now he's doing some aesthetic setting and whatnot before he even gets into the ggplot too. So he's defining, okay, so for each show here, this is where I'm going to want it to appear. So on the x-axis, it's going to appear at the date 1985, 06, 09, and at 790 million. Wow, it's pretty large there. All right.
Big bucks. It's actually kind of sad because they're not making any money in Broadway now for the past 5 or so weeks. So if you think about all that money and now to nothing, it's actually sad.
Pretty stark.
Yeah, for sure.
And then he's generating this Tibble as well lines. So he's for each location. So between 0 and 800 million, draw a Y at or put a point at every 200 million. And he does so unnest that, so it's no longer a list. So if you just quickly look at that, the nice thing about Tibbles is that they can store special values here. So it's a list of each length 5. It's just that value repeated over and over again. And now unnest takes it into a longer Tibble with each value here. He does a little bit of mutations to set it to actually be the label that he wants it to be. So like 200 million, 400 million. He still keeps that Y and X axis. And interestingly, he only wants to record it for the shows Chicago and Jersey Boys. And this will come up in a second once we get into the plotting here.
You could have done the dollars with a scale Y continuous in your GG plot, probably, using the scales package. I think you could have put money in, right?
I think you could have. I'm pretty sure. I'm sure there was a reason behind it, though.
Yeah. All
right. So now into this ggplot 2. So once again, he puts it all into one line. If you do Control-Shift-A on a highlighted value, it's going to reformat it. Personally, I think into a little bit nicer viewing. So he takes this plot data. So that was the really large data set that we generated earlier. And now he's setting all the aesthetics for the plotting. So x-axis is going to be week ending. Y is the cumulative weekly grossing. He's going to group by, so any any geomes that use grouping will now use show to group by. He's setting the color to be the field color, alpha to be the field alpha, and size to be the field size. Now he's drawing the horizontal line, so geome H line means draw a horizontal line. He's drawing them, once again, from 0 to 800 million at every 200 million. For every 200 million. He's setting their alpha, size, and color there so that he's defining the aesthetics of the way it's going to be looking. You could also potentially do this inside of a setting your themes, but this is a little bit more explicit. Next, he uses geom step, and he doesn't define anything here because all the information that you need to know how it should be behaving was already defined in this step up here. Next, he has his geom point. So actually, Patrick and I didn't see this originally. Like we were like, what's going on here? So if you look at his plot, he is let's open that up. At the very end of each line there, he's got the little point. So, it adds a little nice styling to it, because otherwise it'll just be a square stop point there. So it's all about aesthetics.
Real quick, in looking at that plot, what the geom step did, for example, if you look at cats, it's pretty pronounced, and Les Mis as well. You can see there's a point where the line goes horizontal, and that's what if you just use like geom point instead of geom step, it would have connected that that point up to the other point in a more of a straight linear line.
So yeah, geom step. This is the first time that I've come across geom step, and I thought that was a great.
So it must be for like cats in that plot that the geom step, because it's horizontal. I guess that's telling that he's subsetted out the top and 10. It must be for. I'm assuming that through that time period, Cats wasn't the top grossing.
I think it was that it wasn't being shown. So I think Cats.
Was there a time period where they stopped showing it? Cats?
I think so. I mean, I'm not a Broadway buff, so.
Yeah, that could be.
Yeah. All right. So now he's adding in the labels here. So this is from the labels data set. So if we remember back to that is the show name, and then where he wanted it to be listed. So this is like another layer on top of it. So he's already drawn all the lines, but now he's making it pretty. So he's drawing in the labels, and he's using the str wrap. So any cases where it's more than 15 characters, it's going to add a new line to it. So we can see that in some of the plots. We'll bring that up in a second. And then he's defining additional information about whether it should be inheriting the aesthetics from prior, and he says no. This is the location of the horizontal and vertical justification of the text, so he can define where he wants it to live. He's setting the text family to be Anton, the size and the color of that text as well. This is actually where he's defining his, I believe this is the axis labels. So he decided to, rather than using the labels that come with ggplot2, he wanted to draw his own, and so that's what he's doing here. He's taking the lines text there and drawing it in. Here he's doing scale Y continuous, which is another way that you could be approaching this. He's using a function, so labels takes a function that you can define how it should be behaving. So he wanted to scale it by 1,000,000, so it wasn't so large. He's setting the position of the y-axis to be on the right-hand side, setting the limits, and how to expand it. I don't know what that does. Now he's setting the x-axis scale, because the x-axis is a date object. So he's defining how far it should go. So this will go from 1983 up till 2025. Here he's defining some additional labels. So we've covered that a bit. So he's saying don't put any Y or X labels in there. This is what the title of this plot is going to be. But then he's using glue here to define how it should be behaving. And there's this function highlight text that's living within that. We actually didn't see that originally. So that is saying that for the top 10 shows, so color that string purple and make it bold and make it a size font 16. So this is also within his JK MISC package. So that's a pretty helpful one. Here he's defining the little caption that you put at the very bottom. And here's faceting. So this is what generates the 10 different plots. So facet by IDX, so by the show, have 2 rows, and make it as table. This scale whatever identity is telling ggplot to use the actual values that exist in the data set as opposed to trying to scale it, because ggplot2 will try to figure out the best way that it should be doing it based on some decisions that they've made. And this is telling ggplot, no, I know how I want it to behave. Do it the way I told it to behave. Theme JK also comes with JK MISC package. So this is the theming that he's got. He's got some arguments here for based on the way that he wants it to behave. So it looks like he doesn't want grids. He wants it to use markdowns, probably so it'll respect this markdown that he's drawn in here. He wants it to be a dark theme. He's setting the font family to be Anton and the size to be 24. And then this is just some more theme setting. So he's setting the text for the x-axis to be this color, and of alpha 0.2 is in this family Antonio. So let's run all this now that we've explained all of it.
Lots of theme setting.
Oh, I mean, that's what it's all about with styling.
Yeah, if you want to make it look nice.
If you want to get further from the basics, so let's give my computer a little bit. This is it's working pretty hard right now. We've got a lot of data going. All right, but there we go. So as you can see with the STR wrap, the Phantom of the Opera. So this isn't viewing very, very nicely in my viewer screen. So let's see if we can zoom and make it. Is that a little bit better? No, that didn't really help. We know that his plot looked really nice. So let's just go over to that, actually. There we go.
Yeah.
So see cool. The Phantom of, it then put a new line with the STR wrap of the opera, the Book of Mormon. He's got the ghosting there, showing all the trends of all the other plays that have happened. As you can see, most of them kind of are towards that bottom there. And then a few of them just shoot up, like The Lion King, Phantom of the Opera, Wicked.
It's amazing that, like, Cats and Les Mis, look at how long run, just the long run that they've had since before the 1990 period.
Yep. And so the reason also, so we were discussing like why he filtered out to only keep Chicago and Jersey Boys. It's because he wanted to put this text here at the very right. So if he hadn't subset to only keep Chicago and Jersey Boys, it would have listed this y-axis that he's got here, the 800 million, 600 million, on each of these plots here. And so this was a way so he could just keep it on the far right. So that's not usually what you see, but I think that looks pretty cool.
Pretty cool.
Yeah. Well, thank you, Jake, so much for letting us go through and explain your code. I know I had a great time explaining it, and I'm looking forward to using some of these techniques on our next data set, which we will get started. All right, let's close that out.
All right.
And open up R script now. So I'm going to reset my R session. You can do this Control Shift F10 if you're on a Windows machine like I am. I'm sure there's another command if you're on a Mac. All right, so let's get started here. So we're going to load in our libraries like we do always when you're getting started. So tidyverse, per usual. We're going to do some web scraping, so using rvest here so that we can set the paths succinctly, and then cowplot because we're going to do some manipulation of some images towards the end there. All right. So Patrick, maybe do you want to take us through some of these steps here?
Yeah, we've done a bunch of web scraping before from the same site. This time, instead of doing commonly in the previous ones, we've looked at players in the 2019-2020 season. But this one, we're going to pull multiple seasons so that, similar to what Jake did, we want to evaluate teams' performance over time. So we start out with a quick web scrape there, feeding the code, the basketball reference website link that we're interested in taking the data from, the teams portion. And then the HTML node where the table resides on that web page, and then putting it into an actual table.
Yep.
Yeah.
So we scrape that. If you look, some of this scraping is actually due to, if you look at the format of this table here, teams that have links in them are active teams. So they're currently in because there's been a number of teams in the NBA or whatnot that existed, but then don't exist anymore. So we only wanted to keep active teams in here. So what we did here is we scraped and kept only the teams that had a link. So that's what that A is. That A is a node in HTML that says, okay, I'm going to be drawing a link here. This attribute is now going to get us our team code. So Atlanta, Boston, New Jersey, I think. And then we're going to get the team name as well. So, but what was interesting here is there are some teams like the Pittsburgh Ironmen or Indianapolis Olympians that I never heard of. So we will need to do some filtering to remove them. And so that's what this step here is doing. So this is finding all the cases where teams played. So we're going to scrape the same website here, turn it into a table. And like we've done before, pluck to remove the actual table that we care about. Remove all cases where the keep all the teams that played in the 2019-2020 season, and then pull out the distinct franchises, so for distinct teams. So here's all teams that we should all recognize, right? So then we'll go through, and this is going to generate a table of the team code and team name and filter to keep only teams that are active.
Yep.
All right, so we've got a little bit of a function here. So normally it's best practice to list it up towards the top, but this is directly tied to this next step here, so thought it might be better to list that here. So NBA teams, as we view here, is a tibble, where it's got a single row for each code and therefore each team name here. But we want to be looping across and grabbing the information, the statistics for each of those teams. And so currently there isn't a great way to be doing that in Tidyverse that I've come across, at least. So what I like to do is I use a split function. So split comes from base R. And so what it does is you feed in a data frame and then a vector of values that you want to be splitting on. And so for all the cases that are the same level, it'll split on that. So because code is unique for each row, it's going to split each of the rows of this data set into its own tibble as an element of a list. So now it's going to go through, and I'm going to use map from per to go through and scrape the history. So now we're going to go through this function here. It's part of the reason that I wanted to do this is I wanted to set up a function so that I didn't have to do a bunch of copy and pasting for each of the teams. And so functions are a great way to be doing this functional programming. So it's going to feed in .x, which is team table. So pretend it's just this tibble here. So the Washington Wizards, and their code is WAS. So I give a message to myself so I know where it's at, where it's processing, because it can take a little bit of time here. It's going to generate the URL with the team code. It's going to scrape out that information from the website there. There are some cases where column names of the table are empty, and Tidyverse doesn't like that. It throws errors when you're trying to select and mutate and whatnot. And really, we don't care about those. So I'm going to set them to null, which is going to remove them from the data frame. I'm going to convert them all into character so that it's easier for me to process later on. And then I'm going to keep all the cases where the season is not equal to the string season. This table has headers sprinkled throughout the table there to make it easier to read when you're going through it in HTML, but we're scraping it, and so we don't want that. And then I'm going to merge in the team table data frame so that I have the code and team with the data set. Let's run that. Now run through, so it's going through and it's giving me a message for...
The kicker in the function there, if you scroll up a little bit, is really whenever you do a function to scrape a web page automatically like this, is finding the part of the web page, the part of the file path that is changing. And that's what you see there where you have URL. You have the start of the URL, you've identified that by clicking a few of the pages, that what's actually changing and pulling the data from their end is the team code. And then you basically retain the front part of the URL, the end part of the URL, and use that file path function to allow the team code to be what is changing throughout each iteration of that function running.
Exactly. Mm-hmm. All right, so now we've scraped out all teams information there, and because I use DFR is mapping, so now we've got a single data frame that's got 1,544 records there for each of the teams. So it's not massive because we did it by year, but it's not incredibly small. So next step is data munging. So prepping it for the plotting that we want to be doing here. So I'm going to take this active NBA stats data frame here and subset it or select down into a couple of the fields that I care about, because this was actually pretty wide. It had 34 different columns there, and I didn't need all of them. So I kept the team code, the team name, so the franchise name, which season we're in. I renamed the 2PA field, so that's the 2-point attempts, the 3PA for the 3-point attempts, and FTA for the free throw attempts, and then what were the total number of wins and losses, so that we can get a ratio between those two, and then where did they finish in their division. At first I thought this was finished in the NBA, but no. And so I wanted to keep these things, so I figured these are things that the teams can somewhat control, and so we can look at like what is their philosophy as they go through the years. And now I'm going to do a mutate at, so I'm defining for each of these fields, run this function here. So I'm calling them as numeric, because if you remember in the prior step, I converted them all to characters so I could handle them and merge them more easily. So this is going to handle that step for us. I'm then going to calculate the win percentage. So how often what is the total number of wins they have out of the total, or wins out of the total number of games they had. And then I do multiply by 100, so I get the actual whole number rather than a 0.67 if they won 67% of their games. Then I have a flag for if they won their division that year, by finish is equal to 1. Next, I'm actually going to do some regular expression work here. Which can be a little bit funky, but as soon as you understand regular expressions, they're incredibly powerful. So what I am doing here is, let's actually take a quick look at season. So let's look in the active NBA stats. So it's got the format of 2019-20 or 2018-19. And so this is saying that it ran from the 2019 to 2020 season, or 2012 to 2013 season, for example. But I don't need all that information. I really cared about what season did they start in. That was just a design choice that I had. But what I'm telling it is, okay, so use for G-sub, find the cases where there's a grouping of numbers of one or more, then a dash, then find another grouping of numbers that is one or more. And then keep only the cases of that first grouping. So if you look at season here, it'll find, okay, the first group of numbers is 2019, then there's a dash, and then the second group of numbers is 20. So I only want to keep 2019. And then I'm going to convert it to an as numeric. And so that's what's going to be doing at that step here. So next we're going to run a gather. So gather is going to convert it from a wide format into a long format. So that's going to make it easier for me to be doing some plotting here. So it's going to take these fields here, 2-point attempts, 3-point attempts, wins, losses, win percentage, and convert them into, or make it long, basically. So now the value, or the field statistic is going to have entries for each one of these. So 2-point attempts as a string. And then value is going to be the actual numeric value that existed in that field there. And then if you notice that this isn't all of the fields that existed, but that's because I wanted to keep them as wide, because I cared about them for later processing. And then I converted them into a factor so they showed up in the order that I wanted them to be appearing in for plotting. So let's run all that. Oh, I messed something up. There we go, that should solve that. Gotta close out my prior runs. All right, there we go. So now I'm going to go into creating the actual plot. So Patrick, do you want to take us through this step?
Yep. TOI is going to be the team of interest. This is just a simple way of if you wanted to switch from Golden State to Atlanta to Boston, whoever, Cleveland, great team, great organization. You can easily do that without having to recreate a whole new plot. So you start with TOI and plotting data. So we got Golden State. Yeah.
Go Clay, if you ever listen to this.
Yeah.
Go Cougs.
Clay's listening. Yeah, exactly. So you've got a few little kind of pre-processing steps here to get the data that you're interested in for your plot. And then here's where you create the plotting data. So you set your aesthetic, which is basically season, and value, remembering that value is now specific to one of 6 different statistical measures that you've used through your gather function. And you build those into some lines. So geom line color, if the team ID is the team of interest, that's the line that you're going to be coloring. The group ID, the group variable there just says to retain all the team IDs, the other team IDs. And then the alpha is giving us the transparency of the line. So anytime the team ID is the actual team of interest, make them fully solid, and then anytime it's not, make them at an alpha level of 0.8. And so that's where the what you're calling ghosting comes into play.
Mm-hmm.
Scroll down here. Geom point is for any time that they won their division, you basically change the shape. So obviously the stock geom point is obviously a circle. So you use a 23 there, which gives it a sort of like triangle diamond shape, and you colored it in gold. So they basically get the golden triangle when they win their division. Setting the colors here. So scale colors manual means that you're telling ggplot that you want to manually set the colors your own way. And you only need 2 values because it's basically a binary outcome. You're either the team of interest or you're not. And so you have it set to light gray and then light blue being the team of interest. A little bit of label stuff here. So obviously the x-axis is season, y-axis is left blank because remember we have multiple different statistics in that statistics column, which are going to make sense more when we facet wrap them. But so you leave the y-axis blank, you give it a title, you give it a quick little subtitle, and allow it to auto update to the team of interest. And then obviously it's always good when you remove data from somewhere else to give it credit. So that's what the caption is for. You set your Y continuous. This is something that you could do there with the scales function, which is really handy anytime you're dealing with a y-axis where you want a particular numeric value conveyed. It could be dollars, it could be pounds, it could be log axis. Here you're using a comma. So I think these values aren't that big. If we were doing something like the Broadway show, R might actually kick out scientific notation and put something like 3E6. So by setting the comma, it's going to basically put the comma after every 3 digits. Mm-hmm. So that's what you did there. And then you got your facet wrap, which is basically going to give us a facet for each of the individual 5 or 6 statistics that we had there. And you tell R to basically keep this in one column. And since the statistics are on different values, so win-loss percentage is obviously a probability between 0 and 1. 3-point attempts and 2-point attempts are count values. Since it's on different scales, if you set the scale to a free Y, basically that tells R that with each facet wrap, just choose the appropriate scale for that value. And then you have a whole bunch of kind of theme setting to make it look pretty. This is all stuff we've done a ton of in previous screencasts, like setting the panel background and the plot background to that gray color that you wanted. The grid major and minor lines, obviously, again. And then, the size, the face, the color of your axis axis labels and things like that is all there. Remove the legend, so we don't want that kind of cluttering up the data. We don't need the legend because we're only coloring one team. It's not like we're coloring multiple teams per plot. So you could probably go ahead and run all of that.
Here we go.
And we get a nice little plot here.
Give it a moment. Because I need to actually print it.
I think you.
There we go.
There we go. All right. Cool.
So let's actually pop that out.
Yeah.
It's gonna let me? Apparently not. All right.
Something's wrong with your Zoom button.
Apparently, but good thing is I've already run this, so let's open that up. There you go.
There you go. So we got a cool plot of our 4 variables over time since the 50s. It looks like it goes back to. You can see where the 3-pointer started. Not much data was collected on it, and then it was kind of a piece of the normal box score that we know today, right around the 1978 or 79 mark. And you can see right there where the Splash Brothers really took effect. You can see how many times they won their division there, 1, 2, 3, 5 times in a row. If we could have made this as a shiny or a plotly and made it interactive, you could see there is a team in that previous season, in the 2018-2019 season, that did shoot more threes, and I believe that was Houston.
Mm-hmm. You can explore that.
You could explore that, obviously. And then you can see the dramatic effect that the lockout season had. So there's obviously no data there for 2-point attempts, or very little data for 2-point attempts, and for all the variables, really.
Mm-hmm. So this is a fun way to do it. You can also, we also did a quick plot just for you, Patrick, of Cleveland.
Oh, yay. Historic Cleveland Cavs here. So let's see what we've got. We've got clearly the LeBron era in there, win percentage. So there's the 2 years, right? The win percentage there, and then he left the team, and then there's the comeback years, right?
Mm-hmm. So yeah, and then I think it's pretty interesting that the 2-point attempts, because at least in my mind, when we were plotting this, attempts are something that the teams can actually control for. They can go, we were going to make an active choice to go for 3-point attempts over 2-point attempts more often. And you can see here that the years that they won, they were actually towards the bottom of the 2-point attempts of the teams that were playing, but they were at the higher end of the 3-point attempts.
Yeah, it's super interesting. I think if you scroll down, what's the... Yeah, exactly. It's pretty...
And free throw, they're kind of in the middle there. So I guess that's kind of out of their control a little bit, but... Yeah.
The peak there at the 3 points, they didn't win... They didn't win the division there, but right around the mid-90s, those were teams that were really high 3-point shooters. They had Craig Elo and Mark Price. They got beat in a finals game to go to the championship by the Bulls. It's the historic video of Michael taking the inbound pass and making the 3-pointer over Craig Elo, and then he just falls to the ground. But those are some historic teams coached by Lenny Wilkins, Larry Nance, Brad Doherty, Craig Elo, Mark Price, and pretty. Those were like the pinnacle of my childhood. Dating myself there, but yeah.
Yeah. All right. So now we've got those plots there. But a fun thing that you can also do here is using the cowplot function or cowplot library. What you can do is you can add in logos. So NBA, please don't sue. But we thought it'd be fun to add in the NBA logo into these plots as well. So we told it to, all right, so here's the location of the logo, draw the plot, now add the image on top of it and draw it at this particular location. And so there you go.
Official.
Now it looks real.
Yeah, exactly. Steve Kerr is ready for this report.
Yeah. Here, call us up, Steve. We'll send you it shortly.
Exactly.
And then use GG Save to save it. We set it up so the team of interest is updated there. So if you don't need to remember to update it, and you won't accidentally over save what you've done.
Yep.
So we'll quickly run that. And all right, now we've updated. Oh, that didn't render properly, but there you go. All right.
Too ambitious on the x-axis.
Sorry about that. That's my bad.
Steve Kerr's not ready for this one yet.
Yeah, now we'll work on that. But
cool.
So thank you all for listening. Once again, my name is Ellis Hughes. I am you can find me on Twitter at Ellis_Hughes.
And I'm Patrick Ward, and you can find me at Twitter at OSPPatrick, and you can hit both of us up at tidy.explained@gmail. And also thanks to Jake for his cool idea on plotting lines with gray traces of the population behind them.
All right. Thank you so much, and keep exploring your world.